Hi. We're talking now about how to measure things in science class, and I'm going to go through this these notes, which are in your note guide, and you're welcome to pause whenever you need to, so you can fill some things in. The highlighted things are the things that are blank in your note guide, so you might want to make sure that you write them down. Either write them down on Notability, or write them down on a piece of paper, or write them down on your actual note guide, which I've linked in the week 2 assignment list on Schoology. Okay, so in science we use metric system for or the international system of units to make measurements. We're the only country, the United States is the only country in the world that actually doesn't really use, so you're familiar with like feet and inches. We're the only country that does. That's called the imperial system. But in science, to make science equal among all countries and to make it easy to work on the same playing field, we all use the metric system. Okay, metric system works. You have a prefix and a suffix. The prefix is what measures the scale. So milli means thousands of, centi means hundredths of, kilo means 1,000 times, and really those three that are already kind of highlighted right there, those are the ones that you're going to need for this class. So if I were to make like a circle around them, this is not a circle, this is more like a square. It's terrible, bad square. Those are the three that are really important for this class, and it's useful to know how to convert between them, which we'll get into in a second. Okay, so those are the three, and when you want to convert them, the number line is really, really useful. Most of your worksheets have a number line on it, but you want to copy yours down, and it looks like this, and in the middle you've got the base units. The base units are the ones that are the 0 point. And so for us in this class, mostly we use meters, liters, and grams. Okay, meters is abbreviated with an M, liters is capital L, grams is capital or lowercase g. And then this way it goes smaller to the right here, so you've got 2, 3 steps. And those 3 steps, the ones that they all have names, but the ones that are important for this class is that this is centi right here, and centi is a C, and this is milli right there, that's an M, and that's 10 to the negative 2 and 10 to the negative 3rd. We also have things that are bigger than 1, and so that's this direction, and there's more lines, but these are just the ones that you need to know. And then, so this has a name, but you want to go with kilo here, and that's a K, and kilo is 10 to the 3rd, or 1,000 times something. So the number line is really useful when you want to convert. If you want to convert between things, then the number line is super helpful to do that, and I'm going to show you right now how to do that. So in this problem, it says a roll of copper wire contains 15 meters of wire. What is the length of the wire in centimeters? So if you had 15 meters and you wanted to write that out in centimeters, you just start where you're at, and we are at meters, which is in the middle, right? That's the base unit. There's no prefix on it, just the meters. Don't get confused from milli. Milli would have 2 letters, like millimeters or milliliters. But when it's just one M by itself, it means meters. So if you want to convert from meters to centimeters, what you do is you just use the number line and then just change how you are, move the decimal point, however many lines you go. So, excuse me. So here at meters, we're going from 2 lines to centimeters, right? So I'm going to do is I'm going to move my decimal point 2 spaces to the right, the same direction that I moved. So instead of 15, it now becomes 1,500, because I'm moving 2 spots to the right, centimeters. Okay, and you can move to the left too. If I said I wanted you to convert, let's say, I don't know, 5,000 millimeters, and I want to know how many meters that is, you can do the same thing. You're just going to move in the other direction this time. You're going to start at millimeters. That's a little m. And if I'm going to go this way here now, I'm at millimeters. Go 1, 2, 3 spots to the left. So take your decimal point, which is right here. Oops, that's not cool. Decimal point right here, right? And move it 3 spots left. Oh, you didn't change colors. I don't know how this works. Okay, yes. There's decimal point and go 1, 2, 3 spots to the left, just like you move the yellow line 3 spots to the left. So 5,000 millimeters is equal to 5 meters. Both my examples are for meters, but you can use liters or grams. It works the exact same way. Okay, so that is how you convert using the metric system and that number line, which you don't need to memorize. You can use the number line whenever you want. I think it's on most of the worksheets and stuff. But that is a really good tool to use. Okay, so we pair those prefixes with suffixes. I think you know what all these things are, but if you don't, you need to know that length is a measure of straight line distance between 2 points, how long something is. Mass is the measure of amount of stuff that's inside an object, amount of matter. Volume is a measure of the size in three-dimensional space. And weight, we typically confuse weight and mass, but weight is really different because weight is how much, it's your mass times gravity, So it's a little bit different. We use our weight here on Earth, but the reason that you even have mass is because not everything is the same in the universe, right? Not everyone has the same gravity. Not every planet has the same gravity. So mass is a universal constant, where gravity is not. Okay, and then you probably already know all the abbreviations. The abbreviation for length is L, for mass is M, for volume is V, for temperature is T. And then these are the units for each of them. Units for length is meters, for mass is grams, for volume is liters. For temperature, we use Kelvin or Celsius in this class. And the abbreviations are the ones that you put like after your answer. Like if something was 5 meters, you'd write 5M. If it was 5 grams, 5G. If it was 5 liters, 5L. If it was 500 Kelvin or 500 Celsius, you'd write 500K or 500C. We also have some other ones that we'll get to later this year, but they're not really important for right now. They are substance and electric current, which there's a lot of other ones too, but so those are some of the common ones that you'll see in physical science. And I think you've been writing numbers in scientific notation for a while, but if you haven't, just a quick review of them. You can take large numbers and make them, with lots of zeros, make them easy to write in a small format. That's called scientific notation. You can also take numbers that are very small. Obviously, atoms and molecules are very, very small. You can take those numbers and write them and with lots of small zeros in a shorter format, so it's easier to use. Okay, to do that, I think you've done it before, but if the number was, let's say, 50 million. Okay, this is not my best effort. There you go. If you want to write that in scientific notation, the decimal is here, and you move the decimal place left. 1, 2, 3, 4, 5, 6, 7, until you get a number between 1 and 10. So that number would be 5 if I stop there. So you'd say 5, and then I move the decimal spot 7 spaces. So 5 times 10 to the 7th. Now, since the number is bigger than 1, this number obviously is bigger than 1, that means that this is going to be, that 7 is going to be positive. If the number was smaller than 1, let's say it was this, 0.000812, and you want to write that in scientific notation, your exponent is going to be negative. So now moving to the right, 1, 2, 3, 4, stop there because that number is 8.12. That number is between 1 and 10, so you write 8.12. And then I moved it 4 spaces, so times 10 to the negative 4th. Notice it's negative 4 now because this number is less than 1. So you get the negative there. If you want to write numbers in scientific notation to numbers in standard notation, it's just the opposite. So if the number was, let's say, 2.18 times 10 to the 4th, you just start this way and see how it's bigger than 1 because there was a 4 there, not negative 4. So we move to the right. So 2.18 times 10 to the 4, you just go 1, 2, 3, 4. Okay, move it 4 spots. And so I'm going to add 2 zeros, and I get 21800, which is 21,800. If the number is smaller, let's say it's, 1.13 times 10 to the negative 3rd. Since it's negative here, right there, now I'm going to move to the left because I need a number that's smaller than 1. So I go 1, 2, 3, and I'm going to add 2 zeros in front now. So 0.00113 for my number. So there's a quick review of scientific notation. I think you probably have done it before, but if you haven't, hopefully that helps. And there's some practice you can look at if you refer to your weekly guide sheet. Okay, this has been fun. We'll see